In this video, we are going to learn how to procedurally vibrate a particular object. Procedurally means that you're not going to have to animate it, keyframe it. You basically just punch in some numbers like your velocity script, and it'll automatically start vibrating. The second thing you need to know is vibration can be in the form of translation. It could be in the form of rotation. This could be a translational vibration. It could be rotational vibration, or it could be a vibration that's based off scale. So first off, I want you to ask yourself, what kind of vibration do you want to see in the object? Let's assume that in this particular case, I want a translational vibration from this particular object, which is cube_geo. So I want it to vibrate in the translate y axis. I'm going to make that happen through something called as expressions. It's window, animation editors, expression editor. And what this is really is it helps me sort of write mathematical equations and control the translate y of my cube_geo by typing in a mathematical expression. Okay, whenever you open the expression editor, make sure you click on select filter and set it to by expression name. In doing that, you're basically saying Maya should sort all the expressions that you've written in the alphabetical manner, in an alphabetical list. Clicking on that right now gives us nothing because we haven't written any expressions. Once you start piling on multiple expressions, like you might have the velocity expression, you might have the vibration expression, you would be able to see multiple expressions listed out over here. So we will always start out by giving our expression a name. I'm going to call it cube_vibration_expr, stands for expression. Okay, it normally helps for us to type in a comment. You do that by having 2 backslashes or front slashes or whatever this is, and just say script, or let's say expression created by Ashwin on what is today's date? November 9, 2016. Press enter. This is basically the non-executable part of the script, the informational part, and it always helps to sort of write down certain details into this note, if you will. Click on create, and now your expression has been created. Now what I'm going to do is I'm going to develop an expression for you guys, and in doing so also teach you guys how this expression is going to work. I hope that you guys are able to see what I'm typing in here, which is very, very important. If the quality of this video is low, which it shouldn't be, this should be a 1080p video, then you're not going to be able to read it. So full screen it and make sure that you're actually able to read what's going on. Okay, so remember, I haven't had to select anything while writing the expression, so don't worry about selecting an object, and that's because all the objects that are going to be involved in writing an expression will be named right here. Okay, so I'm going to start out with something really basic. Okay, I want to make sure that the translate y of my cube_geo is set to 5, and let's say 5 is an example. I want to set it to 5. I want to make sure that that is something that I do using an expression. So I'm going to write this cube_geo, because _geo needs to be in caps, dot translate y equals 5 semicolon to end the expression. I hope you guys are able to read this. So it says translate y of cube_geo, and you write that by saying cube_geo dot translate y equals 5, and I say, and the expression is obviously not updated until you press edit. And when I say edit, you see that translate y of my cube_geo is now set to 5, and you've got a purple over here. This means that I can simply go in and then change this value right here to say 10, click on edit, and now that is automatically changed, which is fantastic. I can replace 10 right here with a kind of a mathematical equation, if you will, which is what I'm planning to do. You know what I'm going to do is just type in here in my notepad, because I think it'll be easier for you guys to see it. and then simply copy that over here into my expression editor, only because typing in the notepads makes things a little more clear. Okay, so here's what I typed in. Dot translate y equals 10 semicolon. This is what I have, and this is what I've copied over here. Now, that is fantastic. Let me just make this really small over here so that way I'm able to see it. But remember the color, once again, the expressions are going to throw in maybe like a lavender color, if you will, into the channel box. Just like constraints will do blue and connection editor will do yellow, that kind of stuff. Okay, so let's develop this script now. Instead of just putting in a random number into my expression, what I'm going to do is I'm going to say cube underscore geo dot translate y equals time. As time starts to increase, I want the translate y of my cube underscore geo to increase. Okay, remember I'm slowly developing this script. Let me copy this over here. Press edit. Start with 0 maybe. Okay, now see what happens when I press play. You see what's happening? As my time's increasing, if I just make that frame huge, frame range, as my time is increasing, the translate y on my cube, and you can't see it right here, just have to press stop to see it, it's increasing as well. You see that? It's increasing. This is absolutely not procedural vibration. This is procedural movement though, because the cube is now moving without me having to put keyframes on it, which is fantastic. What I really want is I want the cube to actually go up and go down. As time increases, I want the cube to actually go up in translate y and go down in translate y. And guess what that reminds me of? That reminds me of something very similar to a sine wave. This is what a sine wave looks like. I know that you guys have tested this out. You guys at least know about it. This means that as time is increasing, the value is going to go up and down and up and down and up and down and so on and so forth. Let me just cancel, go back to my notepad file. Now instead of saying cube underscore geo equals translate time, I'm going to say cube underscore geo equals sine of time. As time increases, this value, which is cube underscore geo dot translate y, is going to go up and go down, and this is going to resemble, let me copy that, something similar to a vibration but not quite yet. I'm going to say edit, and now let's see what happens when I play it. Up and down. You see, that's the power of a sine wave. It's going to change the value depending on depending on the value of time, which keeps increasing, and it keeps oscillating, if you will, my object in the y. That's what's happening right now. Now this is obviously not vibration by any means. This is certainly procedural oscillation, if you will, but that's not what we're trying to go for. We're trying to go for procedural vibration. Now in this particular motion, there are at least two things that I need to be able to control. I need to be able to control how much the cube is going up and down, if I want it to go further up and further down, and also how fast do I want my cube to go up and down. I have no control over these, and that is going to happen by me adding two attributes into this particular controller, if you will, and I'm going to have to account for those attributes here in the code that I'm about to write. So let's start out by adding those attributes. Let's call it magnitude and frequency. Magnitude is basically how much the cube is going to go up and down, the amplitude of it. Frequency is going to be how fast the cube is literally going to move. And I'm going to have to account for it one by one. Let's start out with magnitude. To account magnitude into your equation, you're simply going to multiply magnitude into sine of time. So your sine of time is simply going to be multiplied by magnitude. Now, the thing is, you can't just say magnitude. Remember, magnitude is an attribute right here. So you have to say the attribute which belongs to which object. Like, you can't just say translate y. You say translate y of cube geo by saying cube underscore geo dot translate y. I'm going to make the same thing happen here. So magnitude is an attribute sitting on cube underscore control. So you can't just say magnitude. I'm going to say cube underscore control dot magnitude. So let me copy that over here, edit, and if I play it, nothing's going to happen because my magnitude is set to 0. If I set it to 1, you should be able to see the exact motion that we were seeing before, which is nice. If I set that to 10, you should see that the cube should traverse more distance now. You see, I can now control how much the cube is moving up and down, which is fantastic. Let's also now account for frequency as to how fast the cube needs to go up and down. And to make that happen, I'm going to simply multiply frequency inside the brackets here. Now, once again, frequency is an attribute and it can't be used like this. So I'm going to go ahead and say cube underscore control dot frequency. Right, so this is frequency is an attribute which belongs to cube underscore control. Let's copy this over, say edit. Of course, frequency is 0, nothing's going to happen. You have to actually punch in a value. Let's say 1. We're going to give you the exact sort of movement that we were seeing before. If I change that to 10, you see that it's going to start moving faster. If I change that to 50, it's going to move even faster. So now I'm able to control the magnitude and the frequency of this object. And of course, I'm moving it without placing even one keyframe, which is fantastic. There's one more issue that I have with this before I tweak these two numbers to make this movement look like vibration or rattling, if you will. And this is my problem. My problem is that the motion here is so uniform. It's up and down and up and down. And vibrations normally are not so uniform. They are very unpredictable. They are random. The amount of distance that the cube goes up by is not the same distance that the cube comes down by. So there is that non-uniformity in it, if you will. So how do I make that happen? To make that happen, I'm going to change my sine function with something you may not have heard of. So instead of sine, which gives me a uniform up and down, I'm going to go with noise. And let me copy this over. Paste this once again here. Edit. And now if I play it, you'll see that there is a certain amount of randomness in that motion. It's certainly going up and down, but it's not uniform, if you will. And now I can go ahead and start tweaking these numbers. Let me reduce the magnitude, whereas I can increase. It might be a little too much. Maybe even less. Are you seeing that? Just by punching in these numbers, I can simulate a vibrational motion, which is exactly what we are trying to do. This is me not having to place even one keyframe, which is fantastic. So this is math at work, your favorite kind of math, trigonometry. And I hope that you guys have enjoyed this video.